Okay, yeah, it's that. Uh, let's start with sensors. So in daily lives, you may already have some experience with sensors, right? Dealing with sensors. Either you heard of that or you use of that, right? Yeah. So uh, can you tell me your own understanding about what is a sensor? So any idea, any thought is okay. Just blow your mind. What is a sensor?
Say just a device that gathers external data.
Okay, that's good. Gather data, right? Gather data. Yeah, that's good. Uh, other thoughts, ideas? Why can I see the message? Hmm. Okay, so try to use your microphone. Okay, yeah. So what else? What else thought you have about sensor? What is a sensor? Yeah. So the student mentioned right gathering data and mentioned gathering external data. So actually, I would like to change the word external to physical world. Yeah, physical world. Okay. Um, so actually, a sensor is an object or a device. So from the engineering point of view, usually we use a sensor which is a device, right? Yeah, either very tiny, small, or maybe very large, right? Yeah, it's a device. But in general, not only the engineering field, in general, uh, so we call it object, okay, object, because sometimes, especially for uh, biological field, sometimes it's not any device, it's just an object, even an organ, right? So you know that in human bodies, in animal bodies, there are a lot of sensors, right? So obviously, you know, they are just some objects, some organs, some units, right? Yeah. So in general, a sensor is an object uh, that performing a sensing task. What is a sensing task? Converting one form of energy in the physical world. Okay, so you see that the keyword physical world, right? Yeah, into electrical energy. Yeah. So actually, this definition is a more general definition, and you can see that actually it's talking about from the uh, physics perspective, right? And from the energy perspective, right? But I have to say that just now the student share his understanding about the sensor is correct. Okay, so from engineering perspective, is to gathering information or data. Okay, is to gathering information and data. But from the lower level understanding, from physics understanding, is to convert the energy from one form to electrical form. Yeah. So here, I would like to emphasize this from the physical world, right? Another is that the conversion of energy, yeah. And from engineer perspective, is to gathering data or inquiring data or information. Yeah. Because in our field, data information is the terms we use, right? Usually we don't use energy, right? Energy is in the physics field. But we should understand this. We should have this general definition in mind. Okay, yeah. And then what is sensing, right? Yeah. So actually here we mentioned that a sensor performs a sensing task, right? Yeah. Sensing actually is the techniques, to gathering information. Okay. So actually sensing is the process, right? It's the process of getting, information, techniques and processes. Yeah. You can see it's also from physical objects or physical areas, right? Yeah. So in a word, from the physical world, any object belongs to the physical world, right? Even humans, animals, plants, right? They all from the physical world. Yeah. Okay. So right now you already have this definition in mind, right? Sensor and also the sensing process. So can you give me some examples about sensors? So based on the definition, based on your own experience, can you give me some sensors you can think of?
Like a light sensor in my car.
Okay, yes, light sensor. What else?
Thermometer?
Yes.
temperature?
Would skin work since like when you touch something you feel it?
What?
Would skin, like the skin sensors?
Oh, okay. Yes. What else? Actually, sensors are, in our daily life everywhere right now, especially right now, right, with the development of, technology. Yeah. So everywhere is, I think it's more than you think, Yeah. So, for example, I believe in everyone's house, there should be some smoke detector, right? Right? Yeah, those smoke detectors, yeah, they have certain kind of a chemical sensor, so the chemical sensor can, detect the smoke, smoke, and then trigger the alarm system, yeah. So that's, also, one kind of sensor, right? Chemical sensor. And, with the whole device, the detector, smoke detector, you also can regard it as a sensor. Okay, yeah, no problem. And actually, not to mention, the sensors, the sensing devices developed by humans. Actually, in the natural world, there are a lot of sensors. So let's use ourselves as the example, right? Our eyes. Do you think our eyes are sensors? What do you think?
Yes.
Yes, correct. Yeah, our eyes actually are sensors, right? Yeah, our eyes can, convert some physical world information, to some signals and to our brain, and our brain can help us to process and to visualize, this information in the physical world. Yeah. How about our nose?
Yeah.
Yeah, definitely yes, right? Our nose can, smell, right? Yeah, can smell. Yeah, it's one kind of sensor, right? One kind of sensor, and also our ears, right? Ears. Our ears can, can inquire the acoustic information from, the physical world, right? From surrounding environment. Yeah. So that's also one kind of sensor. And our tongues, right? In our mouths, yeah, right? It's also one kind of sensor. And our skins, right? Do you think our skin is one kind of sensor?
It's more the
Yes.
nerves in the skin than the skin itself.
Yeah.
Yes, right. Yeah. So you can see actually, a lot of natural, sensors in the world. Yeah. For some animals, that for example, butterfly, there are some antennas for butterfly, right? So those two antennas of the butterfly actually is the sensing units of butterfly. Yeah. So they can use those two antennas to detect some direction information, orientation information, and some more information. Yeah. And like spider, right? We know that spider web, right? Yeah. So actually, the spider use the spider web. Actually use the pressure information on the web to judge what is the position, what is the distance between the object and itself. Yeah. And then it can attack the object and do something. Yeah. Right. So it's very interesting and very amazing in the natural world. So actually sensors, this term is developed by humans, right? Actually we developed this, we are inspired from the natural world. Yeah. Right. Actually a lot of things, most of the devices, machines are inspired from the natural world. Yeah. Okay, so here are the examples I just mentioned, right? So from biology perspective, right? Human body, right? Our eyes can capture optical information, right? So light, yeah. Ears capture acoustic information, sound. Nose captures olfactory information, smell. Our skin captures tactile information, right? So like shape, texture, right? And also, I think something else, like temperature, right? Yeah, temperature, and also pressure, right? So we can also our skin can also capture pressure information, right? Yeah. So okay, this figure shows the whole process of sensing. Yeah. And like I mentioned, in engineer field, we actually the sensing process, can be understood as the data acquisition, information acquisition, data gathering, information gathering process, right? Yeah. So you can see that the major steps in a sensing process, actually two steps. One step is called sensing. The other is actuation. Actuation. Yeah. So why we have these two steps? Actually, because why we do sensing, why we want to gathering some data information, right? Because we want to, either utilize the information to get to know the surrounding environment, right? Or we want to explore further information and provide some feedback to the surrounding environment. Yeah. So that's why we have this both sensing step and activation step. This activation step is to after extract further information, we try to provide feedback. So we call this feedback activation. And for the sensing step, right, you can see it's based on the sensors. The sensors are the devices, the units to get the information data. Yeah. And then after sensors gather some data information, we will do some pre-processing. So here you can see we have this conditioning analog to digital converter, ADC. Actually, they are doing some pre-processing. Pre-processing work. So why we need to do this pre-processing? First, for the conditioning, right? Why we need to do this? Because after sensors gather data, right? So because the data sometimes have noises, right? Yeah. Sometimes the frequency is not ideal. Yeah. Because we just depends on the applications, right? Depends on what kind of sensors they are. So they have different capabilities to gather data from different time domain or frequency domain, right? So the frequencies about the data maybe not the thing all we needed, right? We may only need a certain range of the frequency, right? Yeah. And then for the frequency bands, we don't need it. It's not necessary. So we can try to filter that out. Because if we don't do this, if we don't filter that out, you know, those frequency bands, those data, you know, may affect the you know, feature extraction, data analysis, right? Yeah. So in order to get more accurate information, more, you know, essential data features, so we will do this. We will do this conditioning, and also to remove, try our best to remove noises. And why we do this analog to digital conversion, right? ADC. Because we know that in the physical world, right, in the natural world, all data, all information is analog signal, right? In analog signal form. Yeah. And right now, you know, the system, the device we use to, you know, process data, to analyze data, 99% are digital systems, digital devices, right? Yeah. So we have to convert analog signals to digital signals before we can, you know, process, analyze them. Okay. So that's why we need this ADC to do this job. Yeah, ADC. And after all that is done, okay, and then we go to you know, this part, signal processing, or, you know, data analysis. So for this part, signal processing, sorry, let me erase this. Actually, it's very complicated. Signal processing, data analysis. So here, you know, depends on what data you have, depends on what feature you want to extract, depends on what application, you know, you have, you know, in the end. So you know, this part can be very, very complicated, you know, can involve you know, many operations here. Yeah. So this is because, you know, signal processing can be a single course, you know, for signal processing, and a lot of knowledge involved for signal processing, you know, from the devices to the principles, and then to the, you know, technologies. Yeah. So a lot of things. After signal processing, right? Suppose we already extract features, patterns, you know, in-depth knowledge from the, you know, the sensory data, right? And then, you know, we may want to provide some feedback to the surrounding world, yeah. And then, in order to do that, we need to convert the digital signal to analog signal again, yeah. Because, you know, here we have to use you know, some signals to control actuators, yeah. So we have to do this, and conditioning as well, yeah. So like I mentioned, you know, filtering, right? Filtering, you know, yeah. And then the signal can control the actuator and to provide some feedback. So, you know, the typical actuator, you know, can be some motors, right? Yeah. So maybe I can give you an example, or, you know, for this process to let you understand. Okay, for example, we have a robot, okay, and the robot has you know has you know some light sensor embedded on the robot body, yeah, and the robot can detect some object or some obstacles in front of itself. Once the robot detect that, right, after all this process, right, yeah, and extract the information about the object, the position, the distance, the size, right, and then make decision. The robot, try to avoid, hitting the obstacles, right? And then based on all the information we get, so give some instructions to the robot, to the motors on the robot body, and then the robot will, turn around to avoid the obstacles. Yeah. And then, this actuation is that we give the instructions of the robot to turn around, right? So this is the actuation part, right? Yeah. So after getting the information, the robot provides some feedback. What feedback? Turn around, right? To avoid hitting the obstacles. Yeah. Okay, in general, sensors capture phenomena in the physical world, right? So the can be process, can be a system, can be plant, can be any object. Here the conditioning, you can see that I just mentioned the filtering, right? So here, we may have amplification, right? Attenuation, right? So sometimes because the signal maybe not that strong, maybe strong enough to be processed or analyzed. So we may need the amplification, right? Yeah. And some other conditioning operations like binauralization, normalization. Yeah. So a lot of conditioning technologies. Yeah, depends on how you want to prepare the signal. The ADC converts analog signal into a digital signal. Yeah, and then we process digital signal, digital data, and give output, give feedback. So here are some classifications of our sensors from the physical property characteristic. We can have these types of sensors. Yeah. So you can see temperature sensor. Right. So this one I think is very widely used in in education. Yeah. So I believe for some courses we may already learn the temperature sensors, right? Either just in theoretical form or in practice form. Yeah. We have dealt with temperature sensors, right? Yeah. Pressure sensor. Yeah. So this one seems not that common, right? Yeah, pressure sensor. Actually, in my work, in my research, I use some pressure sensors. Yeah, pressure sensors. I'm not sure if I show my personal website to you or not. Okay, this is my personal website, and for the publication part, let me see. Okay, so for this journal publication, you can see that is human movement modeling and activity perception based on fiber optic sensing system. So this fiber optic sensor, actually I use this fiber optic sensor as one kind of pressure sensor, So we know fiber optic, right? Yeah. So, the light, can be transmitted through this fiber optic, right? Yeah. And how I use this fiber optic sensor as pressure sensor. So I use one, light emitter and one receiver, yeah, connected with a fiber optic cable, right? And deploy this, whole stuff on the ground. And when we step on the fiber optic cable, right? So originally, because the light emitter can send out the light, and the light can transmit through the fiber optic cable, right? And then the light detector can detect the light, right? But when we step on the fiber optic cable, right, because of our weight, we'll press the fiber optic cable, very, heavily, right? And then the pressure from our weight will prevent the transmission of light. And at the detector side, either no light detected at all, or the intensity of light drops a lot, right? And based on the change of light intensity, we can detect, okay, some object is on the fiber optic cable, right? Yeah. So this is the way, the principle that how I can use the fiber optic sensor as pressure sensor, and I use this to build a very large flow sensing system. It's kind of a spider web, right? Deploy on the floor. Actually not just one single fiber optic cable, a lot of cables, and you have to encode it, in a certain way, and to generate some codes. Based on the codes, the combinations of codes, you can, detect more information, like how many, human subjects in this area, and what they are doing, something like that. Yeah, so very interesting. Yeah. Okay, this is a pressure sensor. Optical sensor. Yeah. So optical sensor, I don't have any experience with optical sensor. So because in my research, I don't use that a lot. Because we have cameras, right? Video cameras, and for image video processing field, computer vision field, most of the people use video cameras. It's more powerful. It can detect reachable information, right? It can be visualized. Yeah. So that's why very few people use optical sensor. Yeah. But of course, it depends on the applications, the field, yeah, but I don't have experience with that. Acoustic sensors. So I think this is a more common sensor than optic sensors, right? Because we use microphone, right? Microphone actually is one kind of acoustic sensor, yeah. Mechanical sensor. Motion sensor. Okay, I think motion sensor is more widely used. Is I think is one of the most successfully commercialized sensors. Yeah, motion sensor. So right now, in some buildings, in some rooms, offices, actually some motion sensors installed. For example, in a certain office, the light, right, can be turned on and off automatically, right? And how to do that? There is a motion sensor or a few motion sensors installed, right? And one, human subjects, entered or exit. So the movement of human subjects will be detected by the motion sensor, and then the motion sensor, depends on the direction of the motion of the movement. The sensor can tell, is entering the room or exiting the room, yeah. And the light can turn on and turn off. Yeah. And sometimes when you stay in the room for a while, right, you are not moving, right? There's no motion, no movement. The motion sensor will regard that, okay, there's no human subject, and the light will be turned off. But when you swing your arms, a little bit, right, the motion sensor detects the movement, the motions again, and the light turn on again. So actually for this motion sensor, I use one kind of motion sensor. That is called the pyroelectric infrared sensor. Yeah. So okay, let's see the journal papers. Yeah, so this one, mobile target scenario recognition, low cost pyroelectric sensing system. So this pyroelectric sensing sensors are one kind of motion sensor. Actually, this sensor is very widely used. So in Jack Brown Hall, in the in offices, and I believe in bathrooms, we have this kind of motion sensor installed. Yeah, so it's pyroelectric sensors. So this sensor can detect the motion, the movement of human subjects. Yeah. And actually, how does this sensor detect the movement? Actually, is to detect the heat radiations. You know that human bodies can radiate infrared, right? Yeah, infrared. So, and there are certain special material on the sensor. It can detect that infrared. Yeah. And then when you move, so the infrared radiation changes, and then the sensor can detect the movement based on the infrared change. That's how it works. We can discuss this further later, when we talk about some applications of sensors. Some emerging applications, intelligent applications of sensors. Okay, so let's take a break for 5 minutes. My throat is really hurt. So let's have a 5 minutes break, and we get back. Okay. Okay, let's continue to learn some other sensors. Another kind of sensor, position sensor. So one position sensor you must be very familiar with, GPS, right? Yeah. So we use the GPS signal for navigation, right? Yeah. So almost when we driving, we use it, very often. Yeah. So some other position sensor, ultrasound-based sensors. Yeah. And we know that actually in biological field, right? There are many ultrasound-based sensors, right? Some animals use ultrasound to position, right? Yeah, to navigate. And also infrared-based sensor, yeah. Another kind, electromagnetic, yeah. So we don't use that a lot. Chemical, yeah, chemical sensor. Actually, yeah, it's because we are from the computer science engineering, computer engineering, computer science field, right? So we don't use chemical sensor a lot. Actually, chemical sensors, some are involved in our labs, right? Like I mentioned, the smoke sensor, right? Smoke detectors, like gas detector, right? And sometimes fire detector, right? Yeah, something like that. Humidity sensor. So usually this sensor used together with the temperature sensor, right? Yeah, the temperature sensor. So they can be used to monitor the weather, the indoor environment, right? Yeah, use those sensors. And the radiation sensor. Okay. So these types of sensors are actually categorized based on their physical properties, right? Yeah. And we have other classifications. So if we classify the sensors based on power supply, we can classify them into two kinds of sensors. Active sensors, so which refers to the sensors require external power, external power. So they emit energy. This send out energy, like the energy may be in the form of microwaves, right? Light, sound, and to trigger response or detect change in energy of transmitted signal. Okay. So well, what examples we have for active sensor?
The backup sensors in a car.
What the sensor in the car?
The backup sensors in a car.
Oh yes, yeah, that's one kind of active sensor. And another example I can think of is the sonar system, right? Yeah, the sonar system can detect the object, under the water, right? Yeah. So the sonar system should send out some sound waves, right? And it depends on the reflection of the sound waves to detect the objects, right? The position, the range, right? Yeah. So that's one kind of active sensor. Actually, there are a lot of active sensors. Like the camera. When we use camera to take picture, right? If the illumination condition is not good at all, right? So sometimes you need to open the flashlight, right? Yeah, use the flashlight. The flashlight can provide more illuminations, right? And then you can take a better picture. So actually, you can regard that as an active sensor. Yeah, you can regard it as an active sensor. Yeah. The other kind is passive sensor. So on the opposite, the passive sensor, they don't need external power. I mean, you don't need supply power to them. They can, get power from the environment by themselves. Yeah. So passive sensor detect energy in the environment and their power from this energy input. Yeah. So some passive sensors, like the okay, the example I used, that ferroelectric sensor. Yeah. So it doesn't actively to send out the energy. Actually, it can directly detect the infrared, right? Detect the heat energy from human subjects. So that's one kind of passive sensor. Most of the sensors actually are passive sensors. Yeah. Okay. And based on the electrical phenomenon, we can categorize sensors into these classifications. Resistive sensor. That is to use changes in electrical resistivity. Yeah. Capacitive sensors use the changes in capacitor dimensions or permittivity. Inductive sensors rely on the principle of inductance. Piezoelectric sensors rely on materials that generate a displacement of charges in response to mechanical deformation. Yeah. So you can see these are the classifications based on different criteria, right? Yeah. So we can classify them based on their physical properties, based on power supplies, right? Based on electrical phenomena. Yeah. Okay. So far we actually finished the basic information introduction for sensors, right? And next, let's see the basic information about wireless sensor networks. Yeah, wireless sensor networks. So wireless sensor networks. Put a little bit lower. Here some keywords for wireless sensor networks. Sensor right? So we already talked about a little bit about sensor, and then network, right? Yeah, network. For network, actually, it involves communication as well, right? Communication, yeah. And here is wireless network, yeah, wireless network. So for network, we are more familiar with internet, right? Yeah, internet. And within the internet, we can do a lot of things, right? We can gathering data, we can communicate, right? Sharing source, we can do a lot of things, right? Yeah. You can see that the internet can do some analysis, storage, mining, processing, right? A lot of things. And usually, for various sensor networks, some applications need to connect to internet. Some applications do not, right? Some applications, they can form the network by themselves and involve sensing, processing, computing, decision making, actuating. So the whole process, the entire process, within its own small network. Yeah, some applications they can do that, but some applications they need to internet. They need the internet. They need to send the data to internet for processing or computing. Yeah, it depends. And if some networks they need to connect to the internet, so you can see that usually the node that connect to the internet is called base station. And you can see that the other nodes, right? The other sensor nodes, they gather information and then transmit the information to the base station, and base station transmit the information, the data to internet. So for various sensor networks, we have a lot of sensors. We have multiple sensors, right? Yeah. The number of sensors can be very small. Can be just a couple of sensors, right? Yeah. So sometimes, like in some courses, right, when we use some sensors to form a various sensor network, right? Yeah. So usually we will use just 3 or 4 sensor nodes to establish a network, right? For example, for demo, right? Yeah. So usually for a large applications, we will need more and a lot more sensors. Yeah. So especially the applications that require sensors cooperatively monitor the large or complex physical environments. So like in agriculture or animal monitoring field, so they need to deploy a lot of sensors in the wild environment. And the wireless sensor network acquires information wirelessly, right? Yeah, wirelessly, and transmit the data to a base station. So here is the history, the development of wireless sensor networks. So actually, this term, this concept is developed first by DARPA, Yeah. So you can see there are some remarkable events happened in different years. Yeah. And after this term is developed, this concept is developed, UCLA and the Rockwell Science Center, further develop, the wireless sensor networks, right? And then UC Berkeley do something to promote. So here, the term MOST was developed by UC Berkeley, and right now, in the market for wireless sensor networks, some sensor modes, there are some sensor modes. The term is from UC Berkeley. And then Berkeley Wireless Research Center did a project called Pico Radio project in 2000. And then MIT do this project in 2005. And actually there was a very famous lab in UC Berkeley. They developed a very famous operating system for wireless sensor network, which is called 10OS. So it's a very useful operating system. And they also participate in developing the corresponding sensor modes for 10OS, so with a company. So here you see that this crossbow with this company, UC Berkeley and this company, they developed some sensor modes, for wireless sensor networks, which can use 10OS as the operating system, for the WSN. So these companies commercialize some sensor modes, crossbow, Sensoria, Wireless, Dust Networks, Amber Corporation. So I have used a lot of sensor modes from crossbow, and also from the MAP6. So actually, if there's no this coronavirus, right? If we don't do the online course, if we meet in classroom, actually I can bring some sensor nodes, and we can use the sensor modes to do some practice, and then you will have more hands-on experience about wireless sensor networks, and you will see that some sensor modes from which company. Okay, and then next part is about the communication. Let's stop here today. We continue to learn that next class about the communication in wireless sensor networks. What is the difference between the communication in wireless sensor network and wired communication. Yeah. Okay, any questions? Any question?
You said the PowerPoints would be uploaded, right?
Pardon?
You said the PowerPoints would be uploaded. Would that be today or tomorrow?
Yes, I will be upload today.
Okay, thank you.
Okay. All right, so that's all for today. So if you don't have question, we can leave now. Okay, have a nice day.
Thanks, Professor.
Thank you. You as well.
Bye bye.
Thank you, Professor.